So I'd like to introduce you the turd in the punch bowl of torpedo heaters, master heaters. So you're either watching this because you're interested in a master heater, which I don't know why, but we'll move that aside for now, or you have one that's doing what it's supposed to do, which is broken in some sort of way. What we have here is their 140,000 BTU torpedo style heater. They run on basically any type of kerosene or diesel or any light fuel like that. I've been working on heaters like this since I was like 14, so I know a fair bit about them. And the reason I purchased this was because I'm impulsive, and you can go to your Tractor Supply or pretty much any local place and usually find these in stock, and that's that situation. I knew what I was buying when I bought it, although they have impressed me at just how bad it's continued to get over the last 20 or so years. So we're going to look at some of the problems with this particular one, which it started having problems an hour into its use. We're going to look at, there's some good things in here too, so we'll talk about that as well. But we're going to touch on two of probably the biggest problems with this unit that you're most likely to have. The first problem I ran into was the flame just going out maybe an hour into its life, just randomly for no apparent reason. And now we're having some thermostat issues where it's not shutting off once it reaches its set point. Another note on that thermostat is the differential. So that's the temperature at which it kicks on at and kicks off at. That difference is massive on this thing. When I say massive, I'm talking 15, maybe 20 degree differentials. So it basically runs until you're sweating, then shuts off and doesn't turn back on again until you're shivering, which is not ideal. And I don't know that we're going to be able to do much about that, and we're going to take a look at it. It's probably just a little thermostatic resistor or a metal band style like an old thermostat, so we may not be able to do anything to kind of narrow that range down, but we're going to take a look at that since we got to look at the thermostat anyway. From a build quality standpoint, absolute garbage. The thinnest metal I have ever seen on a heater, especially of a decent BTU size. It's so thin that the top of the clamshell case, they actually had to put these little reinforcing metal clips in because there's not enough metal here for a self-tapper to bite into and hold well. So there's your first sign. Go with a little heavier steel. You won't need to put in these little metal clamps to keep the screws from rattling out of the thing. The chamber itself, not bad. Relatively average, I would say, gauge on it, and it's double walled, and a lot of them are not double walled. That double wall helps to make sure that that tinfoil cover doesn't get too hot, and that's actually an extra. That's a nice feature to have. Starting at the back, and we'll kind of work our way forward. So the air pump on the back, this is just like a little miniature compressor. It's a vaned rotary compressor. Typical filter media, just a piece of foam there. Casing doesn't seem too bad. It's got some sort of fiber reinforcement in the plastic, and these do fail pretty quickly without that, so I'm glad to see that. And they did, for some reason, decide to put a PSI air gauge on the output pump, although it is set higher than it should be right now, right out of the factory. It's pumping like 8 or 9 pounds. That's too much pressure. It should be down around between 6 and 7 for most. That's kind of where they like to be. But really no issues on that end. Motor itself is fine, made in China, old school laminated steel magnet, permanent magnet motor. Nothing really to talk about there, but it appears to be pretty beefy. It's showing 2.15 amp draw on 120 volts. Fan blade is literally loose from the factory. So there's a Allen screw in here. Oh my God, look at that. I can almost take this fan off. It is so damn loose. The fact that that isn't already slipping is amazing. So again, just god-awful build and assembly quality on these things. Now we'll take a closer look at the chamber itself. And the first sign that you just bought a piece of crap is this high frequency or high voltage, almost like a spark plug style ignition source. This was outdated 30 years ago. About 30 years ago, in the name brand torpedo heaters, you started to see, it's essentially just a coil that would glow red when you applied electricity to it, which is way more dependable than these. The transformers burn out because they're running 24/7. Anytime this thing's firing, that transformer's running, this thing's making sparks. And then if that doesn't fail, The actual tips on the electrodes themselves, you know, they erode over time and they wear down. The coil ones just go forever without really having any problem because there's nothing to it. You're just heating up a coil. We've got a photo sensor here that you'll find in just about all of them. It's just looking for a flame. So once you fire it up, it will check that photo sensor, and if after a few seconds that photo sensor doesn't indicate there's a flame in the chamber, it shuts the power down to everything, obviously, so that we aren't pumping fuel into a potential bomb, so that's nice. I am willing to bet our first problem is going to be right here with that ignition. So with a light oil like this, you know, you can spill it on the ground, try to light it on fire, it won't light on fire. It needs a constant source of ignition, and because this flame was going out kind of mid-run, I'm going to guess that we either have a spark problem or we have the electrodes not close enough to the nozzle that's spraying the mixture of atomized air and fuel. Well, yeah, that'd be a problem. So the prongs coming out of this that the spark jumps between is a solid 1/4 of an inch away from where that fuel would spray out of the nozzle. So I'm guessing that just with normal operation, it's just not close enough. It works sometimes, then it doesn't. As soon as that flame goes out, the photoelectric sensor trips, says, hey, we got a flame out, so we better stop pumping fuel, and this shuts off. So we're gonna pull that out, just put a little bend to those terminals and see if that fixes our problem. All right, so I let that run for about a half an hour and she purred like a walrus. So I'm gonna call the ignition issue done for now. And the fan blade didn't fall off, so you know, we're heading in the right direction. Ironically, the heaviest steel I think on this thing is right here holding the control panel together. Go ahead and unplug it, because safety third. Oh, potentiometer. So that's actually even more embarrassing. So they've used, it's not an old school thermistor. They're using digital control with a potentiometer. So there's literally nothing I can do to make that work. So obviously these things are used in all kinds of horrible environments. It's a direct vent, which basically means all of the horrible gases and chemicals that come from burning a fossil fuel, they are safely protected and then immediately sent out into the air we breathe. But at any rate, they didn't even bother to conformally coat the PC boards. So, you know, using this in a house without a roof on it yet or any other infrastructure that's a common use for these things, if this gets wet, it's game over. Like there's absolutely no mitigation for any of this stuff getting even a little damp. None of the connections are glued into place. Everything's just kind of tabbed in. Horrible support for vibration on the board. And just basically everything you don't want to see in something like this that gets dragged around and beat up. Just friggin' garbage. It actually gets worse. So what I thought was a thermal safety switch mounted to the back of the chamber here is actually the temperature sensing unit for the thermostat. So that negates obviously the safety part of it, but then the other part of it is, why the hell would you mount this that close to the chamber, which radiates a lot of heat? Even when there's a fan going over it, when it's that close to the flame, there's heat radiating from that. So I think I'm going to relocate that all the way in the back here where it's getting pure fresh intake air temperatures to base the thermostat on, since we can't do much else here. What an absolute piece of shit. So the last thing we're going to do is adjust the amount of fuel going into that burn chamber, because from the factory it was set too high. And in some cases you want that. So if your torpedo heater is probably a little undersized for your space, you may want to crank that thing up. What you want to try to avoid is having flames kind of licking out of the front of it, which is what this is doing right out of the box, for obvious safety reasons. But if you're in a huge wide open space and you just need to get a ton of heat out of one of these, you can crank that pressure up. It's going to add a little bit of wear and tear on the pump, but nothing that's you'll probably ever notice in terms of shortening its life. But in a smaller space, especially in a space where maybe your heater is too big for the area you're trying to heat and you're short cycling it, so it's kicking on then kicking off almost immediately because it gets the room up to temp so quickly. In order to prevent that short cycling, you can back down the BTU by backing down that air pressure, and just, it may say 140,000 on the side, but you could probably bring that thing down to like a 60,000 BTU heater and still keep flame going. So there is a reason why you would want to get in here and adjust it. For me, I just want to knock it down so we're not shooting flames out the front. So I have put the heater back together. You do need the top cover on this in order to get this right. That top cover does make a big difference when it comes to how much air is going around the burn chamber, and will, you know, you could get it set perfectly with the top off, then you put the top on it, and the thing is way underpowered, or at least it appears to be underpowered. Hopefully you can hear this okay. We got it running, and as you see right out of the factory, almost 8 PSI, which is a solid 2 PSI higher than it should be right now. So we're just gonna go in and make this adjustment, take the adjustment screw here, and we're gonna keep turning it back out. There we go. We're going to stop around 6 and take a look at the front of the flame and see how that looks. Alright, that's about perfect right there. So every once in a while you'll see a little wisp of a flame kicking out, but it never extends beyond the end of the barrel. We got a nice red hot glow around the outside of the ring, and then it softens up to the point. So that's really kind of where you want it. So I have no doubt I will be tearing back into this thing at some point, probably in the near future when the next thing fails. But we've polished this back to at least a working turd for today. I live to see another day. I'll link in the description a couple of better choices for torpedo style heaters from brands that have a long history of actually building a decent heater. But like I said, if you're in a bind and you need something quick and you had to go pick one of these up, they will work. They probably won't set your house on fire, but they're also probably going to give you trouble down the road just from a myriad of poor design, poor component selection, and crap assembly. You're getting what you pay for with these, so just be prepared for that. With that said, they're actually pretty easy to work on, generally speaking. But you know, you don't buy something new because you feel like you need another project. As always, thank you very much for watching. Make sure you unsubscribe and dislike this video. If you have any questions, comments, concerns, and or criticisms, make sure you throw them down in the comments section below me. Otherwise, everybody have a great day.